So I use Advanced Alchemy every time I want to get a nice SQLAlchemy set up with a lot of the details left behind. So it's an abstraction layer on top of SQLAlchemy that makes things a little bit easier compared to when I'm supposed to deal with SQLAlchemy directly. It contains classes, mixins, and helps you to build with a repository pattern if you're familiar to something like that. In this video, that's what I'm going to be looking at, and hopefully I'll also show you how you can integrate this into FastAPI. I've actually made some videos about that, but I haven't really dived into it. So today I'll be focusing on the features of the library, and then I'll be later introducing it into a FastAPI application. Without wasting time, let us get into the video. So to start the video, I'm going to be installing Advanced Alchemy, and I'm going to be using UV to do that. UV is installed on my system, so all I have to do is to go ahead and run the command UV init followed by the name of the folder in which I want to install. Let me call this simple Alchemy. I'll cd into that folder, and then once I cd into that, I can see we have a main.py, API project.toml, and a readme.md. Let me install Advanced Alchemy with the CLI as well as SQLite to help me connect to the SQLite database via an AsyncDB API. So when I enter, both Advanced Alchemy and SQLite are going to be installed. Now that we have that out of the way, let me open the rest of the project in VS Code. With that, we have a very simple UV setup right here, where we have a virtual environment with .venv, gitignore, and the rest of the files. What I'm interested in is a main.py, as that is where we're going to be writing most of our code for this video. The next thing we're going to do is to try to point VS Code to which Python environment we're going to be using. I'm going to be using a Python that is found in my virtual environment. So in case a VS Code doesn't recognize that, I can just click on this simple section right here, and I'll be in position to select the virtual environment I'm going to be using for this project. But since it's selected, I do not have to do anything. The next thing I'm going to do is to now set up SQLAlchemy with Advanced Alchemy. Normally, you would use an engine object to go ahead and set up how you're connecting to your database and stuff like that. In Advanced Alchemy, there is a config object that you need to set up. You can point to it an engine that it can use. You can also just set it up and let's say connect using a connection string. So it will take care of most of the stuff that you'll need. To do that, I'll go ahead and install or actually import the Advanced Alchemy config. So I'll say advancedalchemy.config, which I'll go ahead and import the SQLAlchemy config. But since I'm using an AsyncDB API, I'll use the SQLAlchemy async config class. Once I've imported this, I need to create an object of the class. Let me make this a little bit larger. So this is going to be the SQLAlchemy async config object. Once I have this, let me point you to what it is or how it's defined. So in here, we can see that this is a data class, and it's basically a generic SQLAlchemy config that is supposed to basically take in a bunch of generic types, including a type of an async engine, an async session, and the rest. So when you look at what it is, it's basically one that takes in a connection string. We can connect to a database, so let's go ahead and do that. I'm going to be using SQLite, so I'll go ahead and basically create my connection string. I'll say connection string is going to be, this is going to be SQLite plus SQLite, and then I'll just simply point to a testdb file. So that's how I'm going to connect to my database. And once I've done that, then I'm going to point this to that object. So I'll say that our connection string is going to be a connection string, but we can see other attributes that this can have. If I take you back here, we have this basically defining a lot of things. So we have the create engine callable. We can basically create a function that helps us to return the async engine object. We can point it to a session engine just like we're going to do. And then we can also point it to an Alembic config. That's in case you are setting up Alembic from scratch. But this has inbuilt support or inbuilt setup for Alembic. So with that in place, I can go ahead and set up our sessions. To set up a session, we have to go ahead and import another session config class. And I also think this also is defined as async session config. So once I've done this, then I can go ahead and create this session config object. This session config object is going to be the object I'll provide to our SQLAlchemy config as the session config. So I'll come right here and point to a config. And when you hover over this, you see that this will be just the setup for the configuration objects for our SQLAlchemy async session. If I go inside this object, I can set up things like expire on commit equals false. They're basically those few configurations you may perform when you're setting up your session with SQLAlchemy. You can set up things like auto begin, auto flash, bind, pointing you to an engine, and basically the class you want to create your sessions with, which will default to async session. So this is all stuff you can do with your normal SQLAlchemy setup, but with advanced alchemy, you simply have all these classes that can help you perform those actions easily. Now, once we've set up our config, we can also hook this up onto Alembic. And the way we do that is via the Alembic Advanced Alchemy CLI. So to take you back to where we are, if I run uv run, shall now notice that we have the Alchemy command. But with this, we also have the Alembic command, so you can use Alembic directly, and we can also use Alchemy. So let me show you how Alchemy is. If I run uv run Alchemy, this time we shall see some output. And this output is very similar to what SQLAlchemy with Alembic basically gives us. So we now see the usage options and advanced alchemy CLI commands. It takes in a default config param that we're supposed to provide here. So this has to be the dotted path to our SQLAlchemy config, which is the object we've created right here. So if we point it to main, then .config, that will automatically scan that config and use it to set up our Alembic. We see all the commands right here, which are basically high-level commands or abstractions on top of what Alembic does. So we can see Alembic branches, we can check if the target database is up to date, we can downgrade from one database revision to another, and then we can also upgrade. Basically everything we can do with Alembic can be done via the Alchemy CLI. So I'm going to clear this. Let's now go ahead and simply set up our config. So if I say config, we can, let's say, begin by setting up our migrations or revisions for this project using Alembic. So to do that, I can just run config and then point to the file that contains our config, which is main.py, and then the config object. So this can be source.config or source.db.setup, whatever has that config object. For as long as it's a dotted path, this library will automatically detect it. So since our config is located inside main.py, I'll say that our config is going to be main.config, which is main.py, and then the object will be config. So what I need to do is to initialize or create the migrations within our project. And when I press enter, we shall now see initializing database migrations. Are you sure you want to initialize migrations for this project? Yes. And what that will do is to basically create the structure of Alembic. But this is a customized version of that. If I take you back here, we shall see that we have our migrations folder, which is different from the Alembic folder that you usually see when you're using SQLAlchemy and Alembic. And in here we have the default structure where we have our versions folder where our versions will be kept. We have the M folder. This is like the main configuration or the main file that's responsible for how we shall be carrying out our migrations. We see a lot of things modified in here. For example, we have run migrations offline function and then a do run migrations function. So this will run the migrations with customization specific to advanced alchemy. And then we have run migrations online, and then basically a customized version of a default env.py that Alembic provides. We are going to pay attention to this only when we are adding a database models we've created. And then we can also look at the script.py.macro. This template is also customized to match how Advanced Alchemy expects your migrations to be. So this is a template file you will always use to create your revisions, but Alembic does it a certain way. So the file is always brief when you're using Alembic, but when it comes to Advanced Alchemy, you get much more functions and customizations added to this script.py.macro. So let's go ahead and create our first revision. To create your revision, you have to run the CLI with your config that we created. And in this case, we're going to just go ahead and say make -migrations. And once we press enter, we have to have some sort of like database change. So let me enter a message. So since I do not have anything, I'll be told that I need to create a migration, or I need to have some sort of like change so that I can create a revision for that change. Else, I need to use this node auto-generate option for me to be in position to create an empty revision or empty migration file. But since I'm not into that for now, let me go ahead and create a new database model, a very simple database model for demonstration. To do that, I'll go right in here. Let me create a simple source folder, and I'm going to make it a Python package by using the danda init.py. And in here is where I'm going to, let me actually just also add a models.py file. So this models.py file is going to be where I'm going to create our Alembic or our database model with SQLAlchemy. So one thing I love about Advanced Alchemy is that it also provides for us classes that can help us to add more functionality onto our declarative base class from SQLAlchemy. And by that, I'm talking about the classes that give us audit fields and customize the primary keys we may use for our database tables. To access these, we shall go to Advanced Alchemy.base, and then we shall have a bunch of classes in there. The first one is the UUID audit base class. What this does is to help you be in position to add both audit fields, so those are the created at and updated at fields, as well as the UUID primary key. So the moment you create your base class from this, you are sure you're going to have your database table with the UUID as a primary key, as well as the created at and updated field, which is very important in case you do not want to set that up for yourself. You also get the big int base and the big int audit base. So the big int audit base adds the audit fields created at and updated at, as well as an integer auto-incrementing field. So those are two base classes you get. For this example, I'm going to be using UUID audit base. So what I'm going to do is to create a very simple class right here. And this is going to be a product class. I'll make sure this is a UUID audit base subclass. Now, this is using SQLAlchemy 1 version style of creating database tables. Let me modernize this by using SQLAlchemy 2.0 style. So to do that, we shall say from SQLAlchemy.orm, we're going to import mapped, and then we shall also import mapped underscore column. And from SQLAlchemy, we shall import all these undefined field types. So to change this, I'll have to go ahead and just add type hints so that we just map this onto their respective types and add the constraints using the mapped column field. So I'll do that by coming right here, change this to mapped. This will be a mapped string, and then I will stop using the column and I'll instead go for mapped column. So this will take in, I'll just leave it to nullable equals false for now to keep things simple, and then I'll change this to the column description. So I'll not make this optional. I'll just leave the description to not be null. So let me leave it as nullable for just demonstration purposes. We shall have our price as a float, and then nullable equals false, and then the store quantity is equal to that. I hope you get how to create models with SQLAlchemy. But one thing we can see here is we have our model defined with UUID audit base instead of the declarative base class. And if we look into what this is basically a subclass of very many classes, but most importantly, it is one that actually it is the base for declarative models and adds UUID primary keys and audit columns. I wanted to check the definition and show you the definition of this. So right now we see that this is a subclass of advanced declarative base, which is also a subclass of the declarative base class from SQLAlchemy. Very nice abstraction. So once we have that, we can now go ahead and use our migration setup with advanced alchemy to create this model in a very simple database. To do that, I'm going to copy the name of this model and I'll import it in our env.py so that when we run migrations, the advanced alchemy migrations can scan for it. So I'll say from source.models, we shall import our product class. And once that is done, I'll head over back to my terminal right here and simply run the same command. So this command is going to run alchemy, point to the config we've created, and then make migrations. So we shall be prompted if we need to create a new migration and which message we want to provide. For this case, I'll say create product or create products table. Once that is done, our new revision is going to be created. If I go to my revisions, I have a new file in our versions called this. But one thing that I've also got as a preference is to give my migrations numbers so that I can easily track them and not know which migration, and just make it easy for me to know which migration that I've used. So what I can do is to rename this to just a number. So I can just come right here, remove this UUID at the end, and then replace it with a number such as 001. And I think that's how Django also does it. So one thing I can also do is to make sure that I change the revision ID inside here. So we have no down revision. So all we need to just do is to modify the revision number here. I'll just name it 001, and that will be it. So let's go ahead and update our database with this new change. To do that, we just come and use our command with our config, but instead of running migrations, we shall now go ahead and just say uv run alchemy with the config and then upgrade. So that will apply our revision. We shall be asked if we want to migrate the database to the head revision, and then I'll say here. So this is very similar to how you run uv run Alembic upgrade head. So that will update our database with the latest changes. If you want to look at what that is, I'll open up my DB browser for SQLite, and then I'll navigate to where my database is. That is in my home folder in my simple alchemy, where I've created this test.db file. And we can see now that we have two tables, Alembic versions as well as the products table. If I open the products, we see that we have all our fields as well as those that Advanced Alchemy added for us. For example, we have our ID, which is a binary 16 character string or binary. That's our UUID. We also have the created at and updated time as well as an SQLAlchemy ORM Sentinel field. So that's added by Advanced Alchemy. If you browse data, we currently have our Alembic versions table with a version 001. And then we also have our products table with all the fields we've had defined for us by Advanced Alchemy. So now things are getting a little bit interesting. Let us now go ahead and try to work with our very simple database setup. To do that, I'm going to go ahead and basically add a bunch of stuff to our source code. The first thing I'm going to explore is called repositories. So repositories are basically classes or subclasses that you can use to perform most of the basic operations on the database. So when you're using the repository pattern, this is like the layer of your application where you write your database specific stuff. For example, queries to perform different kinds of operations, like let's say the CRUD operations. So you have already inbuilt functionality for performing such actions without having to ever write the queries to do such things. Let me show you an example. So inside my source folder, I'm going to create a new file called the repositories file. And in here is where I'm going to create our product repository. So to create that, I have to create our repository by importing the class from Advanced Alchemy dot. So this is going to be Advanced Alchemy dot repository. We shall import, there is the SQLAlchemy repository class, but since we're going to be using an async DB API, we shall be using the SQLAlchemy async repository. So what this class does is to basically create for us a central object on which you can call methods that can perform CRUD automatically on our database model. So I'll basically create this and pass for now. So this is the object we shall be calling methods on so that we can perform CRUD on our database model. Now, this right here takes in the model. So if let's say we defined the model as our product, it takes in that model class as a generic type. And the reason for this is to make it easy for us to be able to see our product methods be called exactly on our model. I'm going to be explaining how that works. So when we get to this, it's important that we provide that generic type. So that's going to be our product type. Now I realize I didn't import it, so I have to go ahead and import that. So by doing so, we've customized this repository to work on our product model. And it's going to make sense when we start dealing with calling the methods on this repository. So to go back to main.py, I'm going to start doing some CRUD specific things on our database. So what I'm going to do is to come at the top right here, and I'll say from source.repositories, I actually call this the user repository, but this is supposed to be the product repository. And when I go back here, I'll import the product repository. And once that is done, I'll say if underscore name equals underscore main, then we shall run our code. So one thing I need to do is to now create an object of the repository, and let's say we can now, so this is our product repository, but in here we see an error argument missing for the parameter, so we need to get our session. So how can we access our session? We can use an async context manager with async with, and then from our config, we can call the get underscore session method to help us get our async session object that is created for us, so that we can now basically create our repository with the session. So once we've done this, now let me just actually go ahead and call the function, or put this in a function. I'll define async def main, and then I'll put all this in the function. So now we have to use async IO. I'll import async IO. And once I've done that, I'll simply go ahead and use async io.run main. So let's start by calling this simple function with let's start by exploring all the methods that a repository can give us. So we can say something like result is equal to await repo, which is repository dot, let's say, list. So the list function is one of the many methods on our repo that can be used to list our products. And now, since we provided the generic type, we can see that our documentation for that specific method is going to include customizations to make it look like we are returning a list of products by calling that. So let me go ahead and print this out. If I say print, I'll say print, I'll use an F string here, and I say products and then result. If I run our main.py, let me actually do that in our terminal right here. So I'll say uv run main.py. We now see our product repository has no model type, so that's something that I forgot. We need to provide that in our repository. So that's like a mandatory class attribute we need to define. So the model type is of course going to be the product model. And once we've done that, we can now run our file. And now we see that our products are an empty list. Let's go ahead and populate our database with some stuff. So if I go to our main.py, inside our main.py, I can now create by calling the create object or the create function. So we can actually know what these are by exploring the repository object. So if I go back to my repositories, I can check the async repository class, and now that's the beauty of type hints. Everything is sort of documented very well in here. So I can go see the definition of a certain function so that I can understand what it actually does. And what I'm looking for is the create method or the create function. So there is ghetto absat, and there is let me try to see, there is absat, and then there is absat many, ghetto absat. Let me try to look for add. So there are very many entities, but the thing is there is actually an add method. So that's the method we're looking for. And what this does is to add data to the collection. So it takes in data, which is an instance to be added to the collection, and that's an instance of the model we are trying to create for. So what I'm going to do is to create a new product. I'm going to say new product, and this new product is going to be equal to the product class. So let me try to provide this. So we need to import the product model. I'll say from source.models import product, and instead of calling create, which I got wrong as the name, we shall call await repo.add, and then this will take in the data. So the data in this case is going to be the new product. So I'll say data is equal to new product. And once we have done this, then we'll go ahead and also see what kind of attributes I have here. So I have description, which is nullable, price, which is not nullable, and then the store quantity. So I need to also add the store quantity. So I'll say stock quantity equals to 100. So let's try to create a new product. So when we add, we expect to get that product object. So if I go up here and run our file, we now see our products and we see the newly created products. So let us try to list, or let's actually just confirm with our data right here. If I refresh, I see that our product has not been added. And the reason as to why I think that is happening is because when we call this, we then need to also add an auto commit attribute. So what this does is to run a commit after our product has been added. So that will automatically save it to our database. If I run auto commit equals true and we run our file, this time if I refresh, we shall now see our data added to our database. So you have all these very basic abstractions that help you perform stuff you would have written a lot of SQLAlchemy code for. Hi everyone, if you're enjoying this video, please leave a like. Do not forget to also subscribe if you're new here. Leave me a comment down in the comment section telling me how you feel about the video and what kinds of videos I'll be making. Thank you. Now let's go back to our main.py. We have so far performed 2 CRUD operations, but you can pretty much perform all CRUD operations from here. For example, if you wanted to, let's say, update or insert, or let's say get an item, you'd use your repo. So let's try to modify this. I'm going to remove this entire line right here, move to add. So I'll also change this. So let me kind of get rid of what we have here and call .get. So I think .get is the name of the method that's responsible for helping us get the item. And if the item does not exist, there is something that we are going to get. So when you check the documentation right here, let us actually try to see. It raises a not found error. So let's try to see if I call .get with the item ID. That item ID has to be the string of the UUID of that product, since we are using UUID. So let me get the UUID from here. If I try, this is a UUID, so I can't seem to see it stored as some blob. Let me try to print it out. How can I do that? Let me try to fetch all products through list. And save. So when I run this, we now see our product from the database. So let me try to print the product IDs. So what I'll do is to come right here and say print r.id for r in result, which will be the list of all the model items we have. And then I will come right here, print. So we have our UUID stored in our SQLite as this. I wanted to demonstrate how to use the get. So the get function or the get method in this case will help us to get the item by the ID. So I have to provide the item ID as the UUID, which is going to be that UUID. So instead of printing this, I can just take this back to our result. And by doing this, I can go ahead and return the product with that specific ID. So that's the basic CRUD things you can perform. However, things can even get more interesting. You can list with pagination. You can do quite a lot of amazing things using any of the predefined SQLAlchemy specific abstractions. You can get one, so that basically helps you get an item. You can get one on none. That's important in case you want to catch the none and not return an error, because get will always return an error. You can get or abstract. You can get an item, and if it does not exist, you can insert it in the database, and very many other methods. So that's basically how the repositories will work. You get direct calls to methods you can use, and you can pretty much go ahead and carry out your CRUD. So we can get to delete this item, and then when we call delete, we also have to run the auto commit so that we get rid of it in our database. So I'll say auto underscore commit is equal to true. That is also something that we have on our method. So I need to add a missing comma right here, and I'll save. And when I do that and run our file once again, we now see that that is gone. If I check to confirm, our item will be gone. So that's basically how repositories work. You have a variety of methods you can use to carry out your CRUD stuff without having to worry about the underlying SQLAlchemy queries. And I think this can become very useful in case you are handling multiple things on a very large code base. Another thing I'd like to talk about is services. So think of services as a layer on top of your repository. With services, you get to have these high-level methods that do not do anything SQLAlchemy related. What they do is to basically take in data structures, and they are sort of like the layer on which you perform your business logic. Let me show you an example. So we've created our repository right here. This is going to be the database layer. If we wanted to create the business logic layer, we'd create the service layer in a service file. So let me call this services.py. Inside our services.py is where I'm going to now create a service. To create a service, we have to access advanced alchemy dot service, and in here is where we can basically import the service classes. What I'm going to be using is the SQLAlchemy I'm forgetting what this is called, but let me try to access the service. So we have the async query service, the repository read service, and the repository service. And this is what I'm going to be using at first. So that's the async API, but they also have the sync repository service, the sync repository read service, and the sync query service. So I'm going to be using the SQLAlchemy async query service. Okay, so once we have that imported, we're now going to go ahead and basically create our product service. Of course, we're going to need our repository because we're building on top of our repository. So I'll say from source.service or from source.repositories, I'm going to import our product repository. And once we have that, we can now create our class. So it's going to be our product class. Now this async query service, this basically takes in a repository, and that repository has to be attached to a session. So let's try to look into this. Async query service, simple service to execute basic query repository. So here we provide self.repository and then session. So here we can come and basically provide the service. I don't know if I'm getting this wrong. This doesn't have to take in the type, and I think what we need is the repository. So let me just create it as product service, and then I will async query repository service should be just that, and then we shall have our repository. I don't know if I'm doing this right. Let me consult the documentation. So if I go to our documentation of advanced alchemy and I head over to services, so in here is where we have advanced alchemy.service error messages, advanced alchemy.offset pagination. I'm looking for how to create services. So let me go to repositories, and now I need services. So services in advanced alchemy build on repositories to provide high-level business logic, data transformation, and schema validation. I want to look at how they create a repository, or how they create a service from a repository. So in here, we see that we are creating an async alchemy repository service, and then this takes in blog post. So let's see if we've imported the right class name. So this is a query service. I think I needed to import the repository service. I think I made a very huge mistake. So I'll import the repository. And once I've imported that, then I'll come right in here. I will make this be a repository service. So this operates on a repository object. And then I think the query service works in a different way. And let's see, this actually operates to execute basic query repositories. So there are query repositories, and then there are base queries or base repository objects. And this is exactly what we needed. Now, to see the implementation of this takes in an SQLAlchemy async repository read service with a model, and it can also take in an async repository model class. So let's provide that. So in here, we are too many few type arguments provided for this, expected 1 but received 0. So what we need is to provide the product class. So let me try to provide a product class, and this is our model class. So that's a generic type that's expected in here. So I'm not seeing any type errors. Another thing I need to do, let me see the implementation of this. It just goes straight to the methods. There is not anything like, let me see here. We create the repo. So the repo takes in that and a model type. So we specify a repository type. Since we have our repository already, I think we can basically use that. So let me just come and say that our repository type is going to be equal to our product repository. Done. So once that is done, next thing is going to be for us to now use our service. So a service is very high level, very business logic based, to the extent that we don't have to directly call things on our database. And let me show you how that works. I'm going to remove the inputs of our repository and our model class right here, and then import our service. So I'll say from source.service, import the product service. And once I've imported this, I'll come down here, remove our product repository stuff, and now we are going to be making use of our service. So let's create an object of our service, and this is going to be our product service object or service instance. Now what does this take in? This takes in our session, so we need to provide that. So say session is equal to our async session object from the repository, from our async context manager. And then if we want to, let's say, list or list all our products, we can just basically say await our service dot, and then instead of the list or add, this time we have basically count, and we have list and count. So let's go ahead and see what list and count returns. So here we see this can take in filters, and then we can have other arguments, but let's say it's list records and then returns the total count by a query. So this is a coroutine that returns a tuple that has the sequence of our products as well as an integer for the count of the products. So let's call that and see. If I print products, since we do not have anything, of course, when you come right here, we shall not see anything being returned. So what if we want to create some items? So let me comment this out and then just simply create something. So I'll do that via service dot, in this case, create. But one thing we're going to note is this create takes in a model dict. It takes in a dictionary that has fields that match the model exactly. So in here, instead of providing the model object, what we are providing is a dictionary that has fields that match what we need on our DB. So in this case, we can add, let's say, a sample product, and then we can set for it a sample price. So price is going to be, let's say, a $9.99, and then we can add stock. What did we call that? I think we called it stock quantity. So I'll say stock quantity. So let's say that is going to be 100. Now that will of course just help us to create the item. If I go back to our terminal right here, we shall see that our item will be added. If I refresh, that's not going to work. So I guess there is some other auto commit we have to also provide. So I'll say auto underscore commit equals true. And once I run that again and run to our database, our data will be created. I wanted to just show you how we can list our products. So I'll comment this out and then move here as well as here to show you how that will perform. So we see that our list of products is returned, and then also our number of items is returned. So this is a very simple way you can use SQLAlchemy. And if you're developing with FastAPI, let me actually show you an example of how to use that. You can simply plug it in and you'll have this very easy way to use SQLAlchemy with FastAPI. So let's go ahead and do that. I'm going to go to my terminal right here, and I'm going to install FastAPI with uv-add FastAPI standard. So that is the standard FastAPI installation. Once I'm done with that, then I'll have to go ahead and basically create an advanced alchemy object on top of that, attach it to my SQLAlchemy session or SQLAlchemy config, and we'll be ready to go. We'll basically do most of the things we need to do with FastAPI and SQLAlchemy right inside our advanced alchemy setup. So let me wait for this to install and then we shall continue. Alright, now FastAPI has been installed. Let's go ahead and spin up a very simple FastAPI server. To do that, I'm going to clear most of the code we've had right here, and I'm going to keep a few things. So I'm going to remove this if name equals main statement right here, and then I'll remove our main function right here. So what we need for now is just our configuration of the advanced alchemy. So to set up FastAPI, we shall have to first of all create our simple FastAPI instance. So I'll say from FastAPI, we are going to go ahead and import FastAPI. And once we have been able to do that, we shall go ahead and create a simple app instance. So I'll say app is equal to FastAPI. And then the next thing is going to be for us to now attach our advanced alchemy onto our FastAPI app. How to do that is done through the alchemy object. So FastAPI and advanced alchemy can be integrated using an extension present within advanced alchemy, and that will pretty much glue all the SQLAlchemy stuff with your FastAPI application. To do that, you'll access advancedalchemy.extensions, and in there is where we shall get the FastAPI extension. So let me actually try to access FastAPI, and then I'll basically go to advanced alchemy. That's the object you need right there. So we shall create this object and call it alchemy. So alchemy is going to be our object, and it will be an instance of our advanced alchemy class. So this will take in a config, which is our SQLAlchemy config, and it will also take in the app instance, which is going to be our FastAPI instance. So when I come right here and provide that, so I'll come right here and say app is equal to our FastAPI instance. So now I see an error here, which is a type error. So our config has to be an SQLAlchemy async config or an SQLAlchemy sync config. But then I see argument of type SQLAlchemy config cannot be assigned to parameter config of type SQLAlchemy config, or I think this is fine because this is already an SQLAlchemy config object. So that's basically how we attach the two. If I run my server, I'll do that with uv run FastAPI. For dev, I'll say app. Actually, I think FastAPI will automatically detect my app. So if I run FastAPI dev, my server has to start because all my work is found within my app. Now I'm having an error here. I'm being told that SQLAlchemy config object has no attribute init app. So let's have a look at what is happening right here. If I come to my Alchemy or Advanced Alchemy class, we see SQLAlchemy config or SQLAlchemy async config, and what we provided here is SQLAlchemy async config. So let me go to that. This is an SQLAlchemy async object. So let me try to see what is happening here. We have both our config as well as our app instance. So let me try to have a clear look at what is happening here. We have either SQLAlchemy async config or SQLAlchemy sync config. So I think these can also be accessed via the extensions. So extensions.starlette import config, which is actually interesting because we have to now import those instead of using the inbuilt ones, the ones that we used at first. So I guess I'll have to use those, and let me say from advanced alchemy dot extensions dot, I think I can also access those via the SQLAlchemy async config as well as SQLAlchemy, let me see, session config, which is async session config in my case. So that means I have to get rid of the first import and then use the classes that I was supposed to be using. I even see that the type error is actually now gone. So let's try doing that once again. If I run, and now see that our server is running, and when you go to our browser on localhost 8000, we shall now see our server is now running. But let's have a look at our logs right here. So inside our setup for advanced alchemy is where we can also set up different things, like if we want our config to create our database. So I think all those things can be done via our SQLAlchemy config. So if I come in here, we can have a create engine callable session create all equals false. So in case you do not have migrations, you can basically set the based on metadata.create all inside here, and your database models will be set. But for as long as you have the migration set up, I do not think you need that. So let's try to return some product information from our DB right here into our API endpoint. So to do that, we can use some dependency injection, and the way to do that is by creating a provider or a dependency that will be a callable we shall call within our FastAPI path handler using the depends function. So let me go ahead and create a file. I'm going to call this file the dependencies file. So in here is where I'm going to import our service. So I'll say from source.services import. In this case, I'll go ahead and import our service. So the service we want in this case is going to be the product service, and then we'll simply go ahead and create the callable. So our callable is going to be equal to so we need to basically call this. Let me just say provide, or let me say get product service. So this will give us the service. So we can also make use of our session in here, and how we provide that is through that depends function. So I can have a session, and because you can basically provide dependencies into other dependencies, we can have that dependency called get session. So this will be our first API. We can have this dependency from Advanced Alchemy that returns the session, and then use it in other dependencies where we want to get the session. So let me import the FastAPI depends class. I'll say from FastAPI shall import depends, and once that is done, we can then also create the function we need to use. So I'll say get session, which is going to actually be an async dependency or an async callable. So get session will be a function that's going to return an async generator that will either return an async session object and none. So actually that will be end of iteration. So let's go ahead and import the async session. I'll say from SQLAlchemy or SQLAlchemy.ext.async.io, we shall go ahead and import the async session. And once we have that, that is gone, we shall import our async generator from typing. I'll say from typing import async generator. And now we see an error here. Function with declared return type that must return value on all code paths. So we need to go ahead and implement this. So how are we going to do this? I'm going to go ahead and import our config. So I'll say from, let me actually do some refactoring here. I'll move the code in our main for our config into a file that I'm going to call the config or the db config. So I'll move our config and our session config from this file into another file that's going to be located within our source directory. I'm going to call this our db_config.py. So I'll also have to bring in the imports for the classes that I am using right here. So I'll just cut this or remove it from the main.py into our db_config. So our connection string will just be below the imports, and in here is where we shall go ahead and make use of what we have here. So I have to bring back the Advanced Alchemy class to our main, because that's where we are creating this simple alchemy object. So let me go ahead and import that. I'll just come to our main and say from Advanced Alchemy .extensions.FastAPI import. In this case, shall import the Advanced Alchemy class. Now, for our config to be used, we have to import that. I'm going to be making use of our quick fix. So I'll say from, let's say source, let me just import it directly. From source.db_config, let me remove this. And then from source.db_config, we shall go ahead and import our config object, and that will be gone. And once we've done that, now we can import this without having to cause issues. So I'll say from source.db_config dbconfig, we shall import our SQLAlchemy config, which I called config. Now this is what is going to allow us to get our session. And to get our session, we shall come right here and try async with config dot get session, which is going to be a call to that method. As session, we want to try to return the session or yield the session, and then accept session dot close. I don't know if that's the right way to do that. I'm actually seeing that I have an error here. Result of async function is not used, use await. So I have to call await session dot close. And I think that's the way to get our session. So what we've done here is to create a simple dependency that will return our session. Now we need to go ahead and make use of it in here. So I'm seeing another typing error here that's saying call expression is not allowed in type expression. So let me try to see here. Session depends. Oh, so this is going to be an async session. And then we'll have a default value of the depends our dependency. So what we are going to return by calling this provide or this provider or dependency is an instance of our product service with the session. So shall say session is going to be equal to product. Actually, this session is going to be equal to session. And then we shall just basically import this into where our routes are going to be, and then we just directly import it. So let's try that. I'm going to come right here. I will create some simple schemas. I'll say schemas.py. Inside here is where we're going to have our pydantic schemas for returning our products. So I'll say from pydantic import base model, and then I will create a class. This class is going to be the product schema class, responsible for helping us to read our products or return all the fields on our product. So in here we shall have the name of the product, which is going to be a string, but we shall also have the ID of the product as generated by advanced alchemy. So this will be a UUID dot UUID. I'll go ahead and import this via quick fix import UUID. Next is going to be the description. So this is going to be something that can be nullable. We shall use the optional class, optional string, which will be none by default. So optional is a type shall import from typing. So let me go ahead and import that as well. Nice. So next is going to be the price. So price is going to be integer. Then we have the store quantity. Stock quantity is also going to be an integer. Then we shall have the other fields that are created at. Those will be date times. And then the updated at. So I think this will be also here. But I do not know. I'm just guessing that this will be an optional. So let's try to see an optional date time. That will be equal to none. So let me try to import this datetime. From datetime, import datetime, and then our type errors will be gone. So we can pretty much build a CRUD API onto the simple structure we've done. So to do that, I'll come right here, close most of the things we have right here, and then I'm going to define a routes.py file with our route handlers. So this is a very simple demonstration of how you can integrate this into your FastAPI application. So I'll begin by I can create a router. So let me create a router. I can say from FastAPI import your router. So API router. Once I do that, I can create the product router. The product router is going to be equal to the API router, and that API router is going to be having a prefix of /products. So all our endpoints for products will be here. For this example, I'll only create one endpoint for the purpose of saving time. So I'll say from source.services, I want to go ahead. Actually, I want to use the dependency. So that's going to be source.dependencies. I'll go ahead and import the get product service dependency, and then we shall create our router. So we're going to say products router dot get. So that will be on our root URL. And then I will create an async path handler right here for listing all products. So I want to go ahead and get the repository. So I'll say product. Actually, I'm using the service here. So I'll say product service. And then this will be a service object of type product service, which I need to import. So since this is defined, I can use VS Code to import it. And then we shall use the depends function from FastAPI to make use of our dependency. Let me put this on a fresh line to make it a little bit easier to see. So this will be depends. And then I will go ahead and call get product service. So we shall also have to import depends from FastAPI, and then we shall be good to go. So with all this, we can now return our products. We need to define a response model. So I'll do it in here. Our path will be get / and then we shall access the response model. So in here, we shall just say that our response model is going to be equal to a list of product schema items. So we need to import that as well. I'll say list of product schema. I will go ahead and import that from our Pydantic models which we defined in our source.schemas. And when I call this, I'll save. So going ahead and returning this, we need our products list. So I'll say products is going to be equal to await product service dot list, and that will return our product. So if I say return products, that will be able to return our product. So if I go back to our server is running. If I head over back here and maybe navigate to our Swagger UI on /docs, we shall see no operation defined in spec because we haven't yet registered our route on our handler. So to do that, let me try to move some of the stuff out of the way. I'll move this to tab number 3, and then I'll also move this to tab number 3 as well, so that we have our terminal, our browser, and our routes.py. Okay, so to proceed, we are going to go ahead and simply register our router onto our main application. So I'll go to main.py and import our router. So I'll say from source.routes, we are going to go ahead and import our products router. And then I'll say app, or let me just do it below the Alchemy config. So I'll say app.include router, and then that will be our router, which is going to be our product router. So that will of course bring in our route for our products. So let me try to make the request. So now I have an internal server error. Let me see the mistake I've done. response not awaited, there's a higher chance that the application is raising an exception and the dependency with yield has block with a bare except, try a block with except exception. Okay, so let's see where that is. If I go to dependencies.py, except, let me try seeing what happened here. Except exception as E and print E. So let me try to run this again. Still an internal server error. Response not awaited. There's a high chance that the application's code is raising an exception and the dependency with yield has a block with a bare except. Read more about it in the, but then where is the error? Okay, let me just try to modify what we did here. Let me try to call this with yield, and I see if we shall be in position to figure out what really went wrong. Have an internal server error, and that is telling us that we have a response validation error. So we defined our price as 9.99, but it's defined as an integer, so we have to fix that. If I go to our price, this has to be a float, and then our server will be restarted, and when you try this, we can have our item being returned. So I think I messed up a little bit when I tried to use that try except block. I hope you've enjoyed this video and have found it helpful. You can pretty much perform your CRUD routes and implement your CRUD routes using this method right here. And I've used Advanced Alchemy in some projects. It's a really nice library. It not only provides you with the ability to perform CRUD, but you can perform very many other operations. You can do filtering and pagination. You can write complex queries with things like aggregation and very many other things. You can also perform caching, perform database seeding, and very many other things that I'm not going to talk about this video, or else it will be long. If you've enjoyed this video, please leave the like. The like button is the only way you can allow others to view this content, and also you can give me your opinions on what you think I can cover next. I've been a little bit busy with work, and I hope to get active very soon. Thanks for watching, and I'll see you guys in the next video. Have a good evening. Bye.